welcome back to the course. Let's start to work on another method, the second method, FMEA for product service system, right? I'm sure that you have learned a method called FMEA that is typically applied to product design, mechanical design. And I first explain why a new version of FMEA dedicated to PSS is necessary. Huh? That's number one. And then you will learn the method, FMEA for PSA. And you should be able to use that so that you can actually execute the hands-on work in the next tutorial, right? This has been one of the keywords up until now in this course. There are different kinds of uncertainties in PSS provision, and basic classification, basic categories for uncertainty is shown on the slide. I think this is quite familiar to you. So basically, on the left-hand side, what you cannot control. But on the other hand, on the right-hand side, the type of this uncertainty on the right-hand side is controllable. For example, by increasing your knowledge, collecting information, and so on. And we will be addressing both types of uncertainties in this method. And okay, yeah, all right. So it's a bit. Can you explain the terms in the previous slide? Okay, yep, sure. The terms are aleatory type. This is uncertainty caused by randomness. For example, if you throw a dice, you never know which number will show up. You cannot control, and you cannot reduce the uncertainty regarding which number will show up. No? And on the other hand, right-hand side, the epistemic uncertainty. This is, for example, uncertainty because you don't have specific information or knowledge. For example, let's say the number of students registered in this course. It's not random. Huh? One can know the number or estimate the number based on different types of information. And one can know for sure once the course starts, huh? Right? So these are two different, clearly distinct types of uncertainty. No? Right. And so PSS failure, we can define that as the termination of the ability of a certain item to perform a required function. So, because you are designing something, even in the context of PSS, you see a required function, as in the case of product design. And there is a situation where something happens and the required function cannot be performed. It's terminated, right? So that's how we define a failure in the PSS context. And now the question is, this so-called function, what is it? What can realize a given function? And then in the course so far, I have multiple times mentioned that product elements and service elements, right? So that applies to this context too. So a required function can be realized by product behavior and also service activity. Let's say the required function could be move an object from point A to point B, right? And then you may design a vehicle to help that. to realize that function. In that case, the vehicle behaves, no? And that's the product behavior mentioned here. And then you may design driver for the vehicle, and then driver also needs to drive the vehicle. That's the service activity in this case. So these both of the product components and also service components are typically necessary to realize a given function in the PSS context. And continuing regarding the terminology, the term item here is unclear, I think. And the item here refers to the product components or actors. Actors mean persons, employees, organizations, and users who carry out the service activities, right? You will see FMEA sheet quite soon so that you have a more clear understanding of the terms and the meanings of the terms. And another thing important is the required function must be evaluated from the perspective of the recipient, users, right? For example, if we discuss the function of a lamp, we can define that function of lighting in different ways. But what this means here is a user must sort of appreciate the function of lighting. Otherwise, the function is not realized. No? So that's the meaning of this point. So having said those, PSS failure mode is defined as the way in which a component's behavior, a product component's behavior, or an actor's service activity could fail to perform its desired or required function. And as we discussed earlier, there are various types of uncertainties, and also the reasons why such uncertainty exists can be caused by different things. For example, product, or customer, or provider, right? And if we think about the uncertainty of a product, physical product, U standing for uncertainty, originates from product function, and in this case, a risk from this uncertainty is product malfunction. And continuing with customer's uncertainty, it's possible that customers don't have a correct understanding of the PSS offering, and then a risk in this case is customer's failure in doing the customer's job. And when it comes to the provider, provider's own activity is also uncertain, and risk from that uncertainty is provider's failure in doing a specific job. And business environment is also uncertain to some extent, and it can change, and the risk caused by this uncertainty is a sort of prerequisite for the PSS offering can change, and therefore influence a lot, especially in the case of result-oriented contract, where the provider has a much higher responsibility in providing the result. So from this slide, I assume you understand there are different sources of uncertainty, and then this slide focuses on how those different types of uncertainties result in different types of risks. And don't forget about there is also opportunity for the PSS provider to deal with these types of uncertainty. But in this lecture, I'm first emphasizing this risk aspect because that has been the primary focus of FMEA. Huh? And of course, business typically are very much careful on how the risk should be, could be, or can be addressed in designing the offering. And looking at literature, as you know, FMEA was developed mainly for product design, and this is sort of textbook knowledge. And if you look at the definition of a failure mode of traditional FMEA, it reads the way in which a product or process could fail to perform its desired function. It's very similar to the definition I explained to you for the PSS failure mode. The difference exists in basically this part. The FMEA for product design focuses on product, components of the product, and also the processes of the product, okay? Not about services, huh? Okay? And I'm sure that you have seen this kind of sheet, typically used for FMEA, and nothing new for those of you who have learned the method. I've taken this table from ASQ, available on the website. It starts with, on the left-hand side, it starts with process function. So again, even in the traditional FMEA, they start with a function. What is a function? And then that's the starting point for judging whether a failure exists or not. And then in this sheet, you see an example description for drilling a blind hole with a driller, let's say a thick board, for example. And then there can, a failure can happen. For example, hole too deep or hole not deep enough. So typically these are two different failure modes. And for each of the failure modes, there can be different causes. For example, improper machine setup. And then there are effects from a failure, breakthrough bottom of the plate, or incomplete thread form. And then thinking about a company that executes this process, then usually there is a sort of process standardized and given to the practitioners of this company, saying that you should do this, this, and that. And for example, in this case, operator training and instructions are given to prevent that. And here, there are 3 columns with numbers each. That consists of probability, severity, and detection. And the last column, the 4th column, is product of these 3 numbers, multiplication of the 3 numbers. So the resulting number, named priority, is larger when the probability is higher, and the severity, the magnitude of the impact when a fault happens, is larger. And if the fault is more difficult to find, then the priority becomes higher. Okay? And thereafter, based on the analysis, the recommendations can be derived and filled in this table. So far, is it clear? Yeah? It's about traditional FMEA. Do you have any questions?
Sir, the scale of the rating.
Pardon?
Scale of the rating.
Rating. The question is about the scale for each number. I think there are different ways, and for this course, it doesn't matter. So you can define, for example, between 1 and 5, or between 1 and 10, for example. But perhaps between 1 and 5 is easier, because you, as a project in this case, you don't have more specific information. All right. Then now I'm moving into the PSS context. So on the slide, still you see the traditional product FMEA, right? Failures and cause of the failures, and also measures, counteracting measures. So service has its own failure possibilities and causes of the failures and measures of the failures, right? So clear. And then don't forget to notice this sort of cross sectorial influences. As I have said several times in PSS, systems thinking is so important, so critical. Products and services interact with each other. You need to manage the interactions as well. For example, when you are designing a PSS, you think about the product failure. Right? So let's say engine of a vehicle fails. And then causes of the failure could be service technician's failure. Let's assume a service guy did a wrong checkup, inspection right before that failure happened, right? So that could be a cause of the failures. Huh? And then another example is, let's say if the engine malfunctions, that can be counteracted by, let's say, service center, service people can help when that kind of fault happens. That's a measure from the service point of view. And the measure from the product point of view is that redesign the engine in such a way that the service failure will be more difficult to happen. So that's a countermeasure implemented on the product. No? So do you see this kind of cross departmental interactions? Okay. Now, the very useful sheet is used for the FMEA of PSS as well. Sorry, yeah. The only difference exists in the most left-hand side. In the product FMEA, it was there is only one column, and that was a product process, right? And then in PSS case, there are two columns corresponding to both products and services. And then we start with component, product component, or service actor's name in the first column, and then product component behavior or service actor's activity name. So an example could be product component A is the source of the failure, and then related behavior is what is the what is the process of expected process of the physical product component. Let's say in this case, warning of lack of battery power. So that's an expected product behavior. And then failure happens and fail to warn the lack of battery power. And then thereafter, the same description is applied as in the case of product FMEA. So the only difference compared with product FMEA lies in the first two columns. And everything else can be applied in the same way. But again, one thing should be noted that don't forget about cross-sectorial interactions. That can be relevant for this column and also this column. In terms of stepwise procedure, it's not complicated, it's straightforward. First, you need to describe what PSS is under design. That's step one. And then step two is for determining the physical components and also service actors. Step three, analyze the failures. And then number four, after the analysis, the failures are ranked in terms of the priority and thereafter prioritized. The last step is developing recommendations and also finding new business opportunities is what I already mentioned multiple times. So uncertainty can be used as a business opportunity. So the first step consists of three descriptions. The course material handout is based on this particular paper we wrote a few years ago. And therefore, you can refer to the paper, but for simplicity, I will make some adjustment in the terms used in the upcoming slides, including this one. So one thing is the first item under step one. So define the actors. So actors, you remember from the PSS layer method, actors are described in one layer. So look into that specific layer and describe that information here. And what this small nice picture means is to define the relations between those actors. No? So who provides something to whom? No? So that is additional information. Number two, develop or describe this kind of tree structure. And again, I use the terms that are taken from the layer method. So put one of the customer value, one of the items in the customer value layer, and and deploy that into product components or service actors. No? So meaning that, let's say, if I continue to use the example of the vehicle moving from point 1 to A, then customer value is transport from point A to point B. And that can be realized by, let's say, a vehicle. That's a product, no? Or engine of the vehicle, product component. And a driver here. No? So these are the two, at least two different items that contribute to the focal customer value. Huh? So in the meantime, you don't have to bother the function description of the functions. It's a bit not complicated, but as I said, these materials are taken from this scientific paper. So the scientific paper is much more accurate. We need to define specifically different things. So to simply put, take one of the customer value and describe how the value can be realized, either product components or service activities. No? Then, yeah. Then, what this picture means is describe the chain of activities. So now you see the term activity, which can be taken from the layer method lifecycle activity layer. And you can, I think it's quite useful to describe in different sort of lines, one for provider, another for receiver or recipient or customer, and in between the other line for product component. But it's all about how physical components or service activities behave, or what are the activities performed along these lines. Huh? Any question? Is it clear? Okay, good. Once you have described such a description, and then you can, of course, do the same process to a number of value items. No? You can repeat the same process for step 1. And then in step 2, what you should do is, well, basically, make a correlation between the item and the failure of a certain activity. Like this. No? Correlate what item in the product or service relate to the specific activity for the concerned failure to happen. Okay? So that's step number 2. And then once you have done that, you can analyze the concerned PSS failure considering the customer value you have described in an earlier step. And thereafter, this is a description of a failure mode. When you use the sheet, and then in step 4, you are expected to fill in the number for the 3 columns. And the last column is automatically calculated. And then in step 5, you describe the recommendations in the last column. Any questions so far? Because in the coming slides, I will use a specific example to go through the stepwise method. Okay, good. So this application of a specific case is also described in this scientific paper, but the product used in this case is a cleaning machine used for floors, right? And the objectives of using PSS and FMEA in this case were twofold. Number 1, to address both product failures and service failures. Number 2, to develop measures against those failures and also find new business opportunities. And this application is what we conducted with one of our industry partners, and those objectives and those motivations were given from the industry partner. who manufactures this product and also provides services. So, step 1, describing different pieces of information regarding the actors. In this case, cleaning machine manufacturer is one important actor. Huh? So which is the manufacturer, and then that is described on the left-hand side. And then there is another entity named cleaning service company. It's a service provider. And then on the right-hand side, you see, let's say, building owners who receive the service, right? So you can simply describe the actors and also the relations between those actors like this. And then a tree structure. And in this example, the customer value taken is reducing machine downtime. And this can be realized through these functions, but essentially the involved physical component is a so-called electricity box in the cleaning machine, and a cleaning machine operator and service technician aiming to service, maintain the cleaning machines. And how to describe in the middle, the functions is, let's say, beyond this course. But you don't have to be so specific in how to describe in the middle. But here, you need to correctly correlate the given customer value and the product components and service actors. Okay? And so using this style of frame, you describe different actors in the service technician and operator, cleaning machine operator, and the electricity box. Those items are taken from the previous slide, okay? So in the previous slide, you described physical product components and also service actors, and then you use that in this service blueprint type of description and describe the activities for each of the taken items. And through the description of the previous slides, you come to the point where you can describe the probability, severity, and detection difficulty, and thereby you can calculate how high is the priority for each failure mode. And then you're expected to come up with a recommendation to improve the current situation, to reduce either the probability, either the severity, and either to make it more easy to find, detect the failure when it happens. And the typical way of showing the results that are recommendations are, for example, you may want to add a monitoring center as a new service actor in one of the descriptions, and also that has an impact on the description in the activity levels. So, any question? For those who have used the traditional FMEA, I think it's quite straightforward. So, broaden the scope by including the service elements, and then think about what failure modes are present, and then describe those as a starting point using the two columns on the left-hand side of the sheet, and then reason about what will happen if the failure mode is realized. Okay? I hope it's clear, and in the upcoming tutorial, you use your hands, and an Excel sheet is provided, accessible to you, and fill in the sheet, working on your own specific PSS case. One thing I would like to share with you, I think it's very interesting, is we wrote this in a paper we published about 10 years ago. When you launch something, it can be a product or a service or a software, you need to make sure that the probability of a certain fault to happen is low enough. I don't know about software industry, but when you use any commercial software, you meet a bug. That is sort of accepted. I don't know if it's acceptable, but if it's sort of accepted. And meaning that software commercial vendors have a certain level of acceptability of a certain bug or a certain failure of a software. And now the question is, how high the acceptable probability of malfunction be? In the case of product sales, as I explained earlier, the uncertainty becomes a risk almost always. When something uncertain happens, that is almost always a risk for the product manufacturer. But as I explained, in the case of PSS, because you as a provider have continuous relationship with your customer, and thereby such an uncertainty can be an opportunity for your business. So let's say this graph shows the technology development, the development of the technology used in your offering, product or PSS. And then the vertical axis is the uncertainty, the level of uncertainty. And in the case of product sales, we assume that the level tends to be lower than in the case of PSS because of what I explained. In the case of PSS, you have an opportunity to manage certain uncertainty in a different way than product sales. So we also assume along the technology development, the level of uncertainty decreases, and so which means that in the case of PSS, we can assume the faster launch of the specific offering on the market because of this relationship. So meaning that, let's say, there is a product using a new technology under development. When product is sold to a product user, then you probably as a product manufacturer, product seller, need to wait until a certain point where the uncertainty is low enough. But in the case of PSS, using the same product, same technology, then we assume that the market launch can be earlier than in the case of product sales. So this is, I think, an interesting thing from the business point of view. Okay, I think that was it regarding this method. I'm happy to take any question that you may have. Clear? Yes, please.
Sir, when you say the comparison between the traditional and the PSS,
Yep.
so you said that the PSS focus on each component of product, service, and system. So what could be the component?
Okay. So let's use the sheet for FMEA. There are, I think, two ways of coming up with such component. One way is because you have already a PSS in mind, and then I would assume that you also have an idea for what products will be used in the PSS. And then think about, in the product, what component or which components are more likely to fail. So that's one way of identifying relevant product components, right? And then when it comes to service actor, think about which actor is more likely to fail, which process, which activity is prone to errors, no? For example. So that is one way to come up with the first column. The other way is using this tree structure. You probably have an idea of which items in the customer value layer are more important than others. And then take one of them, for example, and then describe physical components and service actors that contribute to the given customer value. Because this is relatively more important than others, and therefore the severity, the magnitude of a failure when this is terminated to function is large. No? So therefore, that is more relevant than other customer values. So start with the more important customer value and deploy that into physical components and service actors. And then the description in the bottom of this figure will be described in the first two columns. No?
In case failure is coming because of the certain behavior of the user, what do we do about it?
Good question, and I think so. The question was, what to do with a failure that comes from customer side, user behavior, a user as a customer, right?
Yeah.
That is well, basically same as how we proceed with the provider's failure. As Pratul recalled previously, service production is inseparable processes between the provider and the receiver. So I think it's not so meaningful to distinguish between the provider and customer in this case. So these are the two actors that are essential to realize a given service, and how to address a failure of either provider or receiver or customer is basically same. All right. Yep.
It's not still clear, that's why I'm asking.
Yep. No worry. No worry.
Better context. So in our case, we are designing for future education.
Yep.
Where we are providing education online through online medium.
Yep.
But there is a problem with the online medium that the attention span is keep on decreasing. So it is hard to get the attention of the user. So I made the system. It is interactive. You can comment on it. You can,
All right.
Maybe solve problems simultaneously. Maybe
Yep.
some gamification is also there.
Mm-hmm.
But if the user attention is not there, then I cannot do anything about it. So then, in that case, the failure is coming from the user side. That
I see.
His attention is not there.
I see.
That's why my system, which is working at the efficiency,
I see.
but the interaction is not from the user side. How do we deal with that kind of idea?
Yeah. So the question from that project group is because they are working on educational system using, I assume, some software, probably some connection, remote teaching, and so on. And one concern that is related to a sort of failure is the lack of attention of the students. No? And that can be described here. On the receiver layer, a student loses his or her attention. Right? That can be described as a failure mode. Right? And I think that is very logical and following the method idea. And you just follow this procedure of the method. And for example, you can think about software adjustment that could prevent such a failure from a student to happen. No? I don't know how, but I don't know, from time to time, some stimuli given to student. I don't know, that's up to the PSS designer in that case. But the point is, so it's a co-production process. No? Service is a co-production process. Therefore, user may need to make a commitment to the process. Without that, effective service is not received. So therefore, it's an important and relevant question, concern, and from the PSS design point of view. And this method can help you addressing such a failure mode in the same way as product provider failure mode or product failure mode. More question? It means you are ready to use the method on your PSS case. Am I right? Yeah. Good. And let's do so. After, I think, a break or a short break? Or?
Short break.